So for my mechanical rig, I first created the armature in Blender by adding one main bone with Shift A, and then extruding additional bones to build the excavator hierarchy. I created separate bones for the base, arm sections, pistons, and claw mechanisms, and since it was a mechanical rig, the focus was on rigid movement and accurate hierarchy placement. So to speed up the process and to stay precise, I also used the L shortcut a lot in the edit mode to quickly select linked geometry pieces when assigning and separating different mechanical parts. I also clearly renamed all of the bones so the hierarchy stayed organized and easier to manage during animations and constraint setup. A large part of the process also involved adjusting parenting relationships between the different piston bones and arm sections. For example, I had to parent the lower pistons to the back arm section and the upper pistons to the front arm section so they would properly follow the excavator movement chain when the crane arm rotated. Because the excavator rigs rely heavily on hierarchy and dependency, I spent quite a lot of time refining and parenting structures to make sure all of the mechanical parts move together correctly. And also for the claw system, I experimented with controller bones and constraints, so both claws could open simultaneously from a single controller movement. I also attempted to use the damp track or the stretch 2 constraints on the pistons, so they would behave more like real hydraulic pistons and slide into each other automatically as the arm moved. Although the piston simulation did not end up behaving perfectly, it did help me gain a better understanding on how Blender's constraint system works within mechanical animation setups.